The broadcast is now starting. All attendees are in listen-only mode.
So welcome everybody to the talk about SMB Timeline, or how I called it, a journey from a should be 2 hours project to a little bit of more work. A quick introduction about myself. My name is Olaf Schwarz. I work for the Austrian Energy Cert and also the National Cert of Austria. I do a little bit of shameless self-promotion usually on this slide. If you are interested in ICS and IoT showdown dorks, we have a small little project running that I do when I have a little bit of time left. So if you are into finding this stuff on showdown, have a look at the GitHub repository. And if you find something new or errors, please file a request for us to change it. So apart from day-to-day job like standard ticket handling, writing reports and stuff like that, I do incident handling and forensics. And below you can see my Twitter handle. So if you want to stay in touch or later ask a question, just hook me up on Twitter and I'll reply there. So what you will not see today. There will be no game changers and there is not one thing solving all your DFIR challenges. So I mean, usually you have the kind of these talks where people just they explain to you they invented the next thing, big thing, and then you realize, okay, it's not a nice idea, but it's not new and nothing special. So still, I think it's a nice little project and it solves a few things, but it will not change your complete life. What will be discussed today, because I now told you what will not be discussed. So hello, my name is Olaf and I'm here to admit you for things. So I tend to forget stuff that I once learned. So I have to make notes on, write some tools that does the work for me so I don't have to remember all the numbers and stuff like that. And to a certain point, I'm lazy, or as other people say, I'm efficient. But the main thing that we will discuss today is lowering the bar. So everything that SMB Timeline does can, of course, be done manually with tools like Wireshark and T-Shark and stuff like that. But why should you do this manually and remember all the filters and stuff like that? And the result of the tool is a timeline in a text format, so in a CSV timeline. And of course, if I give some random people a text file that you can open, for example, in tools like Excel or other spreadsheet applications, they usually can start searching them right away. If I compare that to people, or if I give a file to people, like, yeah, use T-Shark, seed, pipe, grep, and all that stuff, that will be a way higher hurdle for them. I mean, I love good seed, pipe, grep, awk magic, but at 3 in the night, debugging complex statements on the command line is probably also not something that you'll like to do. So it's about lowering the bar. Now you might ask yourself, but Olaf, why you choose SMB? And that's actually a very, very good question. And after doing the whole work to compile the first version of SMB Timeline and continue to work on the tool, I can only say because I was naive. But the true reasons are listed here. First of all, I started this as a project to learn something. So I decided that I want to understand more about how SMB works, what information is in SMB Traffic, and it seemed like a nice idea to, hey, write a tool to produce a timeline. And as you said in the beginning, I thought first like 2 hours and then it will be roughly working. And other reasons are trends like living off the land, and I think nowadays is no longer living off the land. So attackers use the tools that are already there. And of course, that's SMB in a Windows environment. And SMB is very, very powerful, and even state-sponsored groups like the Tula group, for example, they use PSXX from time to time, and they use SMB as well for lateral movement. So it is something that we see in real incidents, and that we have a need to analyze quickly or get an idea what happened. And the remote procedure call and distributed computing environment is also something that is that I learned in this project, actually, how it look like in SMB, and that it is very, very powerful. But we will see this later on. But keep that a little bit in mind. So, and a few analysis examples. If you are trying to search the SMB communication between two hosts in Wireshark, you can, for example, use a filter like that. Of course, there are always other ways to do stuff, but that's one variant that you can do. And does it look very complex? No, probably not. Is it hard to remember? Not really. But think about the next one. If you want to see all the traffic that reads a file and includes a file name, because that's already enriching the filter to give you better results. If you just use the SMB read, then you will get all the requests for the different chunks of the files. So you have to scroll and scroll and scroll and scroll and search. Unless you have to know that SMB2.cmd 0x is read command in SMB2, and 0x2e is it in SMB version 1. And you have to understand that the file name is in two different fields. So it's a little bit more complex already. And you don't get a unique list of the file names, for example. So you have to do more work. What else does you typically see in Wireshark? You can use these flow graphs, for example. And they're really nice, but they don't go deeper than what you see here on the screenshot. So they are not digging into the deep protocols and what happened inside of the SMB. Of course, you can go for T-Shark as well. So this gives you usernames that have been seen in the given PCAP. You don't have to remember that long name, and it's already hard because there are multiple fields that you have to remember how they are spelled. You have to type in them correctly, and do not forget anything, and then you can pipe them to sort and unique. But this already gives you a drawback here, because if you have, let's say, two sessions with a username, and the first is where you have the username stored in NTLM SSP auth username, then the result is username separator, so comma, comma. And if in a other packet you have the same username, but it's stored in smb.acct, so the last field, you get comma, 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 username. So it's still, you can work through that, but it's not the best thing to do. You can do the same for file names. As I already said, also this will not be 100% unique probably, but you have to still remember how are the fields called. You have to type in them correctly. And even if you have done this, what's next? So usually what we do in especially DFIR is we do timelines. So we did our magic with the filters and mistyped them and redone the whole analysis because we mistyped a filter and stuff like that. Then we start to manually entering our leads and findings into our investigative timeline. And we do this manually, and probably after a while you look like this, or at least I look like this if I do this for a while, except I have longer hairs and a beard. Because it's no fun at all. I mean, sitting there, copy paste, oh shit, I missed the copy once, I have to go back, control the work again. So it's not only no fun at all, it's also inefficient. And if we're talking about doing especially incident response, where usually time to a certain point matters, you should investigate and not waste your time doing this. And if you sit there, copy, paste, copy, paste, copy, paste for half an hour, imagine what you could have analyzed in this half an hour already if you get a better overview. Which brings us to SMB Timeline and an overview about what SMB Timeline does. So first of all, it creates a CSV-based timeline for SMB version 1 traffic. Second, it generates a timeline for SMB version 2 and 3 traffic. I will explain later a bit about the versions and why it is like I implemented here, but just realize it will be 2 CSV files if you do both versions. It can also produce a timeline in the log2timeline CSV output format so that you can just throw it into already existing timelines, let's say from host-based evidence, to enrich your data set. What you can do is you can strip a larger PCAP, so like producing a temporary PCAP to analyze with the SMB timeline filter and just strip out the SMB traffic. So that saves you some time because running large PCAP through T-Shark will take time. So the smaller the PCAPs are, the faster it will be, and TCP dump or win dump are way faster. SMB Timeline also can generate a protocol so that it gives you some information, which filters it has been running, which version, etc. We will see this later on a little bit, and it does some enrichment. I will go into the enrichment stuff a little bit later on the slides. So just bear with me for that. So how does a timeline that is produced look like? Again, it's a simple CSV-based timeline, so you can throw it into Excel numbers and all these spreadsheet applications. What are the fields, for example? So these are not all fields, but just to give you an idea, of course, you have the packet number, so the frame number actually, the TCP stream ID from Wireshark. You have, of course, the date and time, which is UTC, because we get it from a PCAP and it's always UTC. And if somebody asks you, what's the time zone? The only answer is UTC. There's only one time zone, and that's UTC. Then we have, of course, source and destination IP and port combination, quite typical, I would say. We have the parse SMB command. So the idea behind that is the commands, of course, are just numbers, and sometimes there are decimals, sometimes hex. But do you still remember what the SMB read command was in hex? I mean, I've written the tool and I already forgot. So it's like a translation from numbers to a little bit more readable stuff that you have that's easier to understand. Then we include account and domain information that we get from the packets, like this account was used to do this. We can extract file name and path information. We can also extract service and registry information if it's in the traffic. And we have an info field, and that will be a little bit more explained later on. And there are more fields, but just these are a few of the major and interesting fields. So how does it look like now to produce the SMB version 1 timeline? So you use Python because SMB timeline is written in Python. Usually you can run it with Python 3, as you can see in the past. I just used Windows here for an example. You run the script, you give it the parameter, the -1, which means produce a timeline for SMB traffic version 1, and use the file test PCAP. And as you can see in the output, it checks the OS, it checks if it's finding T-Shark in the path, it runs the filter, and it parses the output. So that's just an example, but there is a little bit output shown from the tool just to let you know, hey, I'm still running, I'm doing my stuff. This is the command that you use for SMB version 2 and 3. So you just use the -2 option. And in T-Shark and Wireshark, there are only 2 filters. So SMB dot means SMB version 1, SMB2 dot means SMB version 2 and 3. That's why we don't have a -3 option for SMB version 3. That's just based on how Wireshark and T-Shark are implemented. And you can compare the output with the output you've seen before. The only difference is it applies the SMB2 filter, and it's parsing the T-Shark output for the SMB2 filter. Of course, because we are lazy and we don't want to type 2 commands, you can combine these options. So you can just run -1, -2 to produce both timelines. The timelines will be saved in the local directory. You don't need a file name because a standard file name is applied. That's also to keep it more easier to run the tool against the PCAP. And you can see here that we first run the SMB2 filter and then the SMB filter, but that's just small details here. Okay, let's go a little bit into the limitations that SMB Timeline has. So first of all, SMB Timeline is an overview. So it does not give you all information that is in one single packet. I mean, then you can just use Wireshark or T-Shark if you want to have all information. But it should help you to get an overview, of course. And with including the frame number, you can quickly then jump into Wireshark, open the PCAP. It's Control G, paste the frame number, and boom, you are right at the packet, and you can see everything that Wireshark parsed out of that packet. So keep that in mind. There are stuff that's in the packet that is not shown by SMB Timeline. It's an overview. The second limitation is it's fully depending on the parsing capabilities of Wireshark and T-Shark. That's usually what we refer to as standing at the shoulders of giants. I mean, what Wireshark and T-Shark does with the parsing is tremendous. I mean, it's pretty awesome. But if Wireshark and T-Shark cannot parse the traffic, SMB Timeline can nothing better with that, because it just uses T-Shark to get the data. The current version that is also on the GitHub, which will be in the slides later on, uses the CSV output from T-Shark. And that output has some limitations that are good to know and understand. Usually it's if you have a frame, so a network packet, especially in SMB2. I've never seen this in SMB version 1, but in SMB version 2 or 3, it can carry multiple SMB commands in one packet. And if you think about the situation that you have 3 commands in a packet, and each packet has one parameter A set, then it's quite easy, because Wireshark CSV output shows you all 3 parameters in the specific output field, just separated by commas. But if you have only one parameter A set in 3 commands, it will just give you that parameter. And at that point in time, you do not 100% know to which of the 3 commands does this parameter belong. And that's still a limitation that the current version of SMB Timeline that is out has. That's based on how T-Shark produces the CSV output. And SMB Timeline considers most of the defined SMB commands. That means clearly not all. And here's the list. As you can also see in the chat window, you get the slides later on, and there also will be a recording, so you don't have to take full notes if you really want to know which are left out. But for SMB version 1, it's the deprecated, obsolesced, and obsolete commands, and for and as well, it's flush, echo, find, close, etc. If you analyze SMB traffic and you find a situation where one of these commands would be very useful, please get in touch. Let me know. File a request on GitHub. Hook me up on Twitter. That would be super cool. It would be awesome if you then also send me an example PCAP. I'm more than happy then to implement that, or let's say have a discussion why this is relevant. In SMB2, the list is a little bit shorter. It's just the cancel, echo, change, notify, and OP log break. I simply didn't find a use of these commands. So that's why I didn't include them. The log to timeline CSV output format is, as I said, it mimics the output format of the log to timeline tool, so that you can just throw the results into your already existing timeline from SMB, from log to timeline, and you can combine these evidences and then have a, let's say, a little bit more enriched story to tell. What it does actually is it takes both timelines, if they are there, so the timeline for SMB version 1 traffic and for 2 and 3, and combine them. And it's these two timelines are already enriched. And as I said, enrichment will be explained a little bit later. And we have just a simple option to do that. It's -E, and then you provide the file name. I usually just call it l2t.csv because it's log to timeline CSV. And if you check out the output that is shown in the example, it will just let you know, hey, I'm parsing the timeline output for the extended output file, and that it's all you need to produce your log to timeline format result. There are also some limitations in that thing, because the famous markup string, so modification, access, etc., is not made for network traffic. It's based on file system events, so I had a little bit of a hard time trying to match, hey, this is what's happening in the network, what is it best in the file system. For example, one of the whole SMB protocol is a so-called session establishment. It's like host A says to host B, I want to talk to you. Is that already an access? Should that be a markup string like in the slides? Or do we use the access mark only if a file system or register key is accessed? So it's not that plain simple. In addition to that, it's also that a few SMB commands, they open a file, and if the file is not there, they just create it. And they do not let you know on the network that they just created the file. So it's already hard to decide in a file open command, is that an access or is it also a creation and a birth? So I would still consider the markup string feature a little bit beta-ish, and for sure it needs a little bit further validation and some more practice tests. So again, if you're running the tool, you have troubles with how the markup string is set, let's have a discussion. Hook me up on Twitter or on GitHub, and maybe we can improve the matching. So a little bit on the format from the log to timeline. These are the most obvious fields. So of course, in the date field, we put in the time and date from the PCAP. Like the time zone, it's a UTC. Then we have the markup string that I already explained. The source usually is hard-coded PCAP because that's the source of the event in the timeline. The source type is also kind of hard-coded. It's PCAP, the name of the PCAP parsed by SMB timeline. So if you later on search your bigger log to timeline, you have an idea how this is from the network traffic from this file, and I use SMB timeline to produce this line. So that's just to give you a chance to realize where does the data come from. The user is usually the account that's in the SMB traffic, and the host is the source address. There are more fields in the log to timeline format, and they are a little bit less obvious than the fields I discussed in the slide before. So the type command, it's a type field, of course. What we put in here is the human readable SMB command, plus if it's a request or reply, or request response as it states here. And that's all. So then you can see, hey, this is the SMB read request. And there are 20 SMB read responses. That's what you can get out of this field. The short field is, of course, the type field plus the usual IP source port, direction, IP destination port. So that gives you an idea in the log to timeline output format. The traffic was sent by this host to this host. The description field adds a little bit more stuff in it that also differs from SMB version 1 to SMB 2 and 3, because there are different fields that can be combined, but it includes stuff like the search pattern. So if SMB was used to search for files in a directory, for example, there is the search pattern that we can include. Or if we access the registry keys and we have that information in the traffic, then we include that in the description field. And the extra field includes a lot of the numbers. So a lot of the IDs, it's the frame number, of course, it's the TCP stream number. It also includes the information if the packet was a response, what was the frame number of the request, and stuff like that. And I included the dots here because I will not explain every single field here. We just have an hour, and I'm pretty sure one or two might ask a question, so that will just not fit the time. So the strip feature, as I said, it produces a new temporary PCAP that will be later then used in the T-Shark parsing, and will be the basis for the timelines. Only that new file is processed, and we, as I said, we use TCP dump or WinDump for that, and that's purely based on performance matters. So using TCP dump versus T-Shark, if you try it out, you will realize that TCP dump is much faster. And you can see the filter that is used here. As I said, it's just for performance reasons. So we strip down the PCAP as good as we can. So we use port 445 and the port range, of course. So that's all included in the new PCAP. You don't have to use it. You can run the tool also on large PCAPs. It will just take a little bit longer, depending, of course, also on your machine. How do you strip the PCAP? You just use the -S option, nothing more. And then it does all the magic. There is a drawback in here. So as of today, the temporary PCAP later on is removed, which gives you a hard time finding the frame number that you have seen in the timeline in the originating PCAP, because they no longer match. In a newer version, I will change the cleanup function a little bit to give you a more granular option to keep that stripped timeline. So the protocol, it includes, of course, the SMB timeline version, the platform the tool was run on, which G-Shark and Wireshark version was used. It includes also the filters, and it produces some text with the limitations and explanations, and also the log to timeline output mapping. And why is that in the protocol? Usually, if you have a tool and it's a little bit more complex, then you try to understand how the tool works, what are the limitations, which is very important in, especially in forensics. You have to know what the tool does and what the limitations are, but also in incident response and other areas. And what I try to do with the protocol is to include a few of these basic documentation in the tool, so in the protocol, that I cannot find that packet that I'm looking for in the timeline. I stripped the PCAP. What was the filter that is used? You can look it up in the protocol. And if you keep the protocol, you can also look it up 2 years from now. Hey, I used SMB timeline. What was the filter used at that point in time with that version? You can look it up in the protocol. So this keeps a part of the documentation in the tool. It still gives me a hard time to keep this up to date in the new development version, but I hope I can keep up with that level that it is now, so that I really include all the important stuff in here. The protocol does not include a hash of the PCAP file, and I thought about this for a while, because of course it adds extra time that the tool needs. If you run a MD5 hash shard 256 hash on a 6 GB PCAP, That takes time. I mean, that's just how it works. Excuse me. And I then took the decision to not include a hash in the protocol, because if you are analyzing the PCAP, it's already evidence and you should already have your preferred hash stored somewhere else. So there's no use to run a hash again. And if you just rerun the tool against a new PCAP or the same PCAP, for example, we don't waste time producing hashes over and over and over. So the enrichment, and I promised this now for several times in the talk, the SMB traffic carries distributed computing environment remote procedure call stuff. In SMB1, it's usually in the SMB transport command. In SMB2 and 3, it's in SMB IOCTL and in read and write, which was a big surprise for myself when I analyzed the traffic, like, oh, that's in the read. I thought it was just read files, but that's how SMB is. And what is carried in these protocols, that's what I call sub-protocols. That's probably not the right term, but I use it as a working title, and now I refer to it as sub-protocols. And I listed a few below here, and we will go through them now a little bit to give you an idea, so you don't have to already know what all the acronyms say and oh yeah, I've seen this already. It's all old stuff. And now it's where the enrichment comes into play. So the info field and the SMB action field are enriched. And now let me give you a small example here. The WinRec protocol, Windows Remote Registry, operation number 15. Does it say anything what has been done? Probably not. I mean, unless you are doing this on a day-to-day basis, you will probably not realize what it means. So what the enrichment does is the SMB action is set to SMB transaction because it's in SMB version 1 in the SMB transaction part, and it's base rec open key command. So that's what the 15 in the opnum is for. And if you compare now 15 versus base rec open key, what you can understand from that, then hopefully you already understand better what the command does with the description base rec open key. What it further does is in the info field, it adds a little bit of text. So it says open specified key for access returning a handle. Okay, so now you know that this command opens a specified registry key to access it, and the return value is just a handle to that key. If we again compare it to the information 15, I hope this brings a quick and easy understanding what the packet does. So a few of the sub protocols. We have SAMR, Security Account Manager Remote Protocol Client to Server. That's the official name actually. And it's a management functionality for account store or directory. So if you can see the 3 commands that are just as an example here, you can use that sub-protocol that is carried by SMB to create users in a domain remotely, or to delete users, or to change the password of a user. So again, the opnum is enriched in the timeline to include these strings that are hopefully better explaining what the packet does. So that's one example of the enrichment process in the SAMR protocol. We have this server service remote protocol. It's for, let's say, add shares. It also enabled named pipe access, and named pipes are also still popular by the bad guys for intercommunication, and it's part of SMB, and PSExec also uses named pipes. And here also it's just a few examples. So the opnum 14 is net share at, 28 is net remote TOD. So what does TOD stands for? sub-protocols is really rich, and there are a lot of standards that you can read, and there are a lot of opnoms. So I definitely have read too much of this while doing the tool. One of my favorites is Windows Remote Registry Protocol, and it is what it is. I mean, it is what it said. You can do remote registry administration over this protocol carried by SMB remote procedure calls. And you can have registry key deleted, as you can see here with the opnum 7. You can open a key, you can open the local machine key, so HKLM. And usually they return just a handle. So in the return value, you don't get the name of the key that is opened. But you can still easily see in the traffic, hey, there is somebody doing remote stuff in the registry. Which IP does it? To which IP should that be the case? If not, you have an investigative loop that you can clear on later. Is that valid or not? Should that be the case or not? So the Service Control Manager Remote Protocol, yeah, service configuration. I mean, also remote from one machine to the other over SMB. It just works like a charm. You can create service, you can start services, and usually if you start a service, you use just a handle in the traffic, so you have to open the service first, and that's where you should get the service name. So it's really a rich field that you can use in SMB Traffic, and that you can use also for lateral movement. And creating a service is still one of the main persistent features that the bad guys use. You just use an executable that looks very similar to a standard Windows executable, put it on the system, create a service, boom, persistence done. So it's good to have a way to quickly analyze if that's in your SMB traffic, if that should be the case. Then we have the task scheduler service remoting protocol. I just included one example here. I think it's just 4 or 5 opnums, but I cannot remember 100%. The opnum null, it just adds a job. So it remotely adds a job on the target machine, and in the traffic you can see, for example, the command that will be executed in the task scheduler. And that's included in the timeline if we can parse it out of the traffic. So you can quickly search for that in your timeline. We have another sub-protocol is LSAD, Local Security Authority Domain Policy Remote Protocol. And you can see here as well, it can be used to administer accounts. So it can create an account, you can add privileges to an account. And again, what do the bad guys when they are in the environment? They do persistence, and from time to time, they create their own users, or they change users where they already get the credentials and put them into privileged groups. And that's also something that you can spot in the timeline if that should be the case or not. So, a few things I learned about SMB traffic and Wireshark while compiling the first version. First of all, SMB commands are not unique between version 1 and 2 and 3. So what does that mean? Actually, the command in hex 01 in SMB version 1 is SMB delete directory. So it deletes a directory, or at least it tries to. The same command, so hexadecimal 01 in SMB 2 and 3 is the SMB 2 session establishment. And that's for other commands as well. So if you're searching for one specific command in SMB 1, it does not need to be the same in SMB 2 and 3. So be aware. Wireshark field names, you have the SMB fields and you have the SMB2 fields, and they are also not always the same. So you cannot go and dynamically replace SMB with SMB2 and you're done. So as you can see here in the example, the file name is smb.file for version 1 and smb2.file name for 2 and 3. And the account is also different. If you dig down to the subprotocols, how I call them, it's also a little bit strange, or let's say not so easy. So in the Windows Remote Registry Protocol, excuse me, the key name can be in multiple fields. So there is the open key.key name, there's the create key.name. It's not key name, it's name in this time. And for example, there's the load key.key name. So you also have to remember all these field names if you want to get the key names out of the traffic. Or you use SMB Timeline, for example, or other tools that can do this. I already said that packets can carry more than one SMB command. I've seen this usually in 2 and 3. And I already explained the CSV output problem that we have when we have 3 SMB commands in one packet and only one parameter A. Then we cannot for sure say which of 3 commands that the parameter belongs. So we have time for a quick demo. So let's see if the video runs. So this is how you can call SMB Timeline. Let's say on a Linux version, you use Python 3, the tool, you use the file. We produce timelines for both or all 3 SMB versions, and we write a protocol and we produce an extended output. And I've just run this on a smaller test PCAP, which is stored in the evidence folder, and you can see here it already started running. So checking the OS, checking where's T-Shark, running the filter, parsing, and it gives you, this is the current development version, so it gives you a timing that it needs for the steps. And now we are already in the extended output. And now that the tool is done, and this was real time, so I didn't trick in the video. And to give you an idea, so the test PCAP was a little bit close to 300 megabyte. That's just SMB traffic. The timelines produced are 19 megabyte and 14 megabyte. The protocol is quite small, but it's in the same directory. The L2T output is 56 megabyte. And if we have a quick look into the protocol, we see the version of SMB Timeline on top. We have information about the platform that was running the T-Shark version, a little bit information about the system that I used on. And then you can see below all the filters that I used listed here, the files and some explanations. If you're interested in that, you can just look it up on the GitHub page or try out the tool, produce a protocol, and have a read. So it doesn't make so much sense spending time on this part in the presentation. So how does a timeline now look like? I redacted a little bit of the data here to protect the innocent. So you have the frame number, as you can see, and I also reduced the SMB action. So that's just the AT scheduler job ad. So yeah, of course I removed the times. The time zone is there. Then you have source, destination IP address. You have the ports, of course. Here you have the SMB action, which is the enriched SMB action. So the trying to explain what the command does more than just a number. This is the info field. So add single AT task to the task store. Then you can see the status if it's a request or response. I removed the SMB part here because it included the IP of the target machines. And next comes the SMB file. So that's the endpoint on the target system. That's the AT SVC, because that's the pipe that we are using. We have account and domain. I also removed that, and then you have search pattern is not set here, requesting host name is not set. And here you see the service info that I mentioned before. This is the command that was created for the task. And of course, I removed the name of the executable file, again, just to protect the innocent. But this is how it looks like. And of course, you can scroll more right on the timeline, but then there are all the numbers, etc., like the session ID and stuff like that starts. So that's just a quick look how the timeline looks like. And of course, if you run it on larger PCAPs and do not filter the timeline as I did before, you will see the session establishment, etc., as well in the timeline. Whether you can get the tool, that's the link to the repository. As Gareth pointed out in the chat, you can download the file, the slides, and there will be a recorded video, so you don't need to take a note on this one. You can look it up later. There's also some explanation on the GitHub repository. And if you're interested in the tool, please go there, check it out. Which brings me to the point, license. So SMB Timeline is free to use, redistribute, and reuse. And there are no limitations. And with no limitations, I really mean no limitations. So if you want to use the tool in a commercial incident response, please feel free to do so. If you want to use the tool in a training material, please do so. If you want to steal parts of the code and write your own tool, please do so. There's really no limitations. If you reuse, of course, attribution is always nice, but it's not mandatory. A few of you might now ask why no limitations. First of all, I did this as a learning project, and I said this in the beginning. So I wanted to combine writing a tool and learning stuff about SMB, and I already achieved that goal, so I'm fine with what happened, to be honest. Second is I see this a little bit of a contribution to the DFIR community from myself. To be very honest with you, I would not be where I am today without free content of others. And I mean this really like it states there. There are a lot of people out there that just produce tutorials, tools, and stuff like that. And I've learned so much from people giving away free content to others that I also wanted to contribute. And if someone really wants to steal the idea or the code, then I will not be able to prevent it anyhow. I mean, there might be a way, but as I said, I'm too lazy, and it doesn't make so much sense to me. So that's the reason why there are no limitations. What's next to come? As I said, with the CSV output, there is a major problem in the multiple SMB commands per packet. So I worked on the JSON output that T-Shirt can produce for a while now, and I'm nearly finished. So it really looks good that I can replace the CSV output that I now use completely or roughly completely with a JSON output of T-Shark. And that solves the problem also with the multiple commands and parameters, because then it's like this parameter belongs to this command for sure, because that's how the JSON structure looks like. I did some experiments with JSON stream parsers in Python, which gives me a horrible performance. But I'm now back to a good performance, so that it performs roughly the same way as the CSV output that you have seen before. So that makes me quite happy. You need more temporary disk space if you use the JSON function. So the PCAP that I've used before, which was a little bit below 300 megabyte, it produces a JSON file over 1 gigabyte for, I think it was just SMB1. So keep that in mind, that you need larger temporary disk space. So I'm currently, as I said, I'm nearly finished. I'm still validating the results. Sometimes the JSON format is a little bit tricky because the fields are depending on the SMB command or the subprotocol command are in a different area of the JSON structure. So you have to define traffic that includes the command, that includes the timeline, and really dig down. Okay, this is where the SMB2 file name is for this SMB command. That does not mean that in the JSON output for another command, it's still on the same spot. So I'm still validating results, but it looks good at the moment. And the CSV method will be deprecated in the future. So I will probably keep it in and give you a switch if you want to use the legacy function, but keep in mind, and I will also include a warning then in the tool, that this function will no longer be improved. So any new field that is added will only be added out of the JSON output, or any error that is corrected will also be just done for the JSON output. And what I'm also trying to do before I release the next version on GitHub is a native Plaso output. So a body format, because as you have seen before, the log to timeline output for that 300 meg PCAP is a little bit below 60 megabyte, and running that through Excel or other spreadsheet applications is not the most handy way to do it. Of course, it works, and you can still use seed pipe, grep, and awk magic, which performs way better than Excel, but it's a little bit more complicated. You have to know more. So what I'm trying to do is add another flag that you can produce the native Plaso output that you then can use log to timeline, how it's called, psort, I think, something like that, to produce smaller slices in the CSV format so that they are more easy to handle in your favorite spreadsheet application. And with that, we are ready for questions. So if you have questions, you can type them in the chat window and I will try to answer them. I think Gareth already explained how to do that. So if there are questions, type them in. We have something about 6 minutes left, so there's time for questions. So no questions. I'll just wait a little bit. Somebody wants to type a longer question. So as I said, I'm working on a new version of SMB Timeline, and I hope I can release it in the next 4 weeks. So I didn't mention that in the beginning. It's a spare time project. So I just do this in my spare time when I commute with the train. Thanks to COVID, there is no longer commute, which is not good for my time in implementing stuff like that. But I hope it's 4 weeks. And I will announce this on my Twitter account, of course, or you can just monitor the repository. Every version will be published there. And I hope there it will be just 4 weeks. And if you find anything that you want to discuss for the tool, then hook me up on Timeline. Have you used the tool within SOA where keeper is pulled from data source and the tool does its magic considered? Have you? Can you explain the acronym? SOAR. I've right now no clue what it means. I mean, what you can do, the tool can be run against standard PCAP. So if you have traffic recorded, okay. Yeah, of course. Thanks for security, orchestration, automation, and response. So have you used the tool within SOAR where a PCAP is pulled from a data source and the tool does its magic considered? So, I mean, that's just how you use the tool, I would say. So if you have a PCAP and it's produced by whatever tool or in whichever environment, as long as you can read the traffic, you can just throw it in. And then you have a text file. So if you have an idea that you say, hey, from the timeline, I just want to have this and this and this output, you can produce the timeline and then again use a script to parse out the stuff that you want. And from the CSV file, it should also be easy to let's say, write a script that put it into any database, for example. So there are other questions now. You have mentioned the video of this webcast and the slides would be available. Can you go over the directions on how to access them after we are gone today? So the slides will be available via the SANS My Webcast thing. It's also in the chat window. So Gareth explained that. And the video will be on YouTube. So from the presentation, I'm not sure if I will publish the 2 small demo videos because they will be in the large video. And of course, the video will be on the SANS YouTube channel. So more questions. Much appreciated. Pitch this to the team as part of incident. Yeah, it would be cool if more people start to use the tool and also give some feedback. So if there is anything wrong, I mean, time that I can use to test tool or go hunting for PCAPs that have example data that I can use is also limited. So really, if you find something, hey, this is not considered in the tool, or this is where the tool was super awesome, please let me know. Both is highly appreciated. We have still 2 minutes left. So if there is no further question, we are at the end of the presentation. And always remember, Chuck Norris can delete the recycle bin permanently. And with that, thank you for your time. If there are questions later on, as I said, hook me up on Twitter or via the GitHub page. And with that, I would say have a good night. Thanks for your attention.